some others will join as we get going here. This was an added session to our virtual assembly, and I'm glad that Kevin was able to put this together and get some wonderful panelists for us to talk this morning on a very important topic. Let me jump into my little intro here. For those of you that haven't joined us before, welcome to Planning and Conservation League's 2023 California Environmental Assembly. My name is Howard Penn, and I am the Executive Director of PCL. Our focus this year is on extreme measures for extreme times, and I'm sure everyone would agree we have to act now. For those of you that don't know PCL, since 1965, we have worked on statewide environmental policy and issues and focus on land use, transportation, water, energy, wildlife and their ecosystems, and environmental laws such as CEQA, as well as a number of other topics. We combine these areas of priority to reduce the impacts on climate change, climate crisis, and work to remove the contributors to the climate crisis. All of us that work in this climate field have a massive job to do, and we truly appreciate your support, participation, and engagement in any way possible. So let's get started. We are pleased to have you join us today for 2 sessions with presentations and a discussion on how do we make massive methane emissions reductions now, and can offshore wind in federal waters be responsible? Our morning session right now will start at 9 and it will end at 10:30, and then we'll have a little break, and after our later morning session starts at 10:45. So let me go over some helpful information for our sessions if you haven't been with us before in these virtual assemblies. Each day there are 2 sessions, one starting at 9 and one 10:45. You can join them using the same Zoom link, and are welcome to attend as many sessions over the next couple weeks as you would like. There will be a 15-minute break between each session, and you can leave the Zoom session running or log back in, whatever your preference may be. There will be a Q&A period at the end of each session, so if you would like to participate, please enter your questions in the Q&A feature. We like to reserve the chat box for comments, but if you could put all your questions in the Q&A box, it makes it easier for the moderator. These sessions are being recorded, and a link to those recordings and presented material will be emailed to you soon after the session, or you can find them at pcl.org/registrantinfo. And our wonderful assembly coordinator, Johnny, can put that URL in the chat box for you right now. There will be a feedback form once you leave this session. Please fill those out to let us know your thoughts. It really helps us in planning for future assemblies and these type of virtual sessions. So we really appreciate any feedback you can give us. If you have any questions, please contact events@pcl.org. And if you would like to support PCL's assembly and our work in general, please consider donating at pcl.org/donate. I want to give a big thank you to all of our sponsors, but especially our gold and silver sponsors. We couldn't do this without everybody. Chatton Brown, Karstens and Mintier LLP, National Wildlife Federation, Sage Sweetword, and Shoot Mahaly and Weinberger LLP are our gold and silver sponsors. Okay, let's get going with our first session. How do we make massive methane emission reductions? I want to thank and introduce the moderator, Kevin Johnson, PCL Board Vice President, Chair of PCL's Policy Committee, and a land use and CEQA attorney. Take it away, Kevin, it's all yours.
Howard, thank you very much. Good morning, everybody. I am very excited about this panel. When we were putting this together and inviting people, I was just bursting with, new information that I was getting and new ideas. So we're going to get right to this right now. Our first panelist is going to kick things off is Ken Alex. He's the current director of Project Climate at the University of California, Berkeley's Center for Law, Energy, and the Environment. Many of you know Ken. He spent 8 years as the senior policy advisor to Governor Jerry Brown, the director of the governor's office of planning and research, and the chair of the Strategic Growth Council, focusing on climate, environment, and land use issues. Before joining the governor's office, Ken was the senior assistant attorney general heading the environmental section of the California Attorney General's office and the co-head of the office's global warming unit. From 2000 to 2006, he led the California Attorney General's Energy Task Force, investigating price and supply issues related to California's energy crisis. Ken is a graduate of Harvard Law School and holds a BA in political theory from the University of California at Santa Cruz. So with that, Ken, please take it away.
Thanks very much, Kevin and Howard and PCL. Methane is one of my favorite topics, so I'm going to do a little bit of background, and the rest of the speakers will be talking about more specific sets of issues. Let me see if I can share my screen. Let's go. Okay. All right. And if I can figure out how I move this to the next slide, it'll be okay. Okay, so first thing I want to do is give you a little bit of background on methane. So, and you're probably aware of this, but just as a little refresher, colorless, odorless gas forms when organic material decays, and so it's primarily in oil and gas operations that doesn't require decay, because that natural gas is basically methane. About 70 to 90% of natural gas is methane. The decay is in landfills with organic material, cow stomachs, rice, and here's the key point to know that is really, I think most people don't know. Methane accounts for fully 1/3 of Earth's warming to date. It's been really ignored as compared to CO2, but in fact, methane is hugely important in the climate system. It's starting to get a little bit of its due over the past couple of years, and now we have a global methane pledge, which was sponsored at the last meeting, Conference of the Parties, worldwide meeting around climate change, sponsored by the US and the EU. There's about 120 plus countries now that are part of the global methane pledge, the key pledge of which is a 30% reduction of methane by 2030. So let's, okay. And here's the thing, methane is a huge greenhouse gas. It may be even more important than CO2, but at least it's second. But it also provides a big opportunity. You can't get to where we need to go in terms of keeping below 1.5 degrees or even 2 degrees warming unless you take care of the methane emissions set of problems. It's 84 or so times as potent a greenhouse gas in the atmosphere over a 20-year period. And I will underscore the 20-year period because I want to talk about that a little bit later as well, because there's some different ways of calculating the impact of methane. If the other thing is that it stays in the atmosphere, unlike CO2, which can be in the atmosphere 100 years or more, if you stop emitting methane in about 15 years, that methane will disappear from the atmosphere, and that gives us some more time to do what we need to do to deal with climate change. So the next, all right. The next thing I want to talk about is that methane, because it's natural gas, basically, is a product, and as it says here, it can be redirected for profit. And in fact, many of the large investor-owned companies, oil companies, are now saying that they think that they can reduce methane in the oil and gas sector by 30% by 2030. And what that tells me is that technologically they can do it, and they think it's not going to cost them a huge amount of money. So, all right. Now, I want to go quickly through some of California's existing policies. As with many things, California was first to really focus on methane and short-lived climate pollutants, sometimes called super pollutants. In fact, 2006, as you can see, SB 605 required strategy for methane and other super pollutants. I will say that with respect to methane, going back to 2006, while there was a strategy, there wasn't a lot of action taken. California was quite effective around black carbon, which is another short-lived super pollutant, but we'll leave that to another session. For methane, the SB 1383 is now sort of the gold standard. California, again, was first to have a very specific requirement for methane reduction. And as you can see here, it's a 40% reduction in methane by 2030 from the amount of methane emitted in California. And in addition to that, or in conjunction with that, a 75% cut in organic landfill waste by 2025. That is going to be extremely difficult to meet, and I will be fairly shocked if we're able to get to that 75% cut in organics in 2 years. So we shall see, but it's a significant piece of the 40%, so it's quite important. And as you can see here, 1383 provided quite a lot of money for dairy digesters, alternative manure management, et cetera, and investments for landfill recovery infrastructure. So California is still, there are not many laws around the world that are like 1383 still, and there are countries and jurisdictions that have goals for reduction, but nothing requiring it in the way that California does. Okay, what else do I want to say here? All right, well, the scoping plan, which is the blueprint that the Air Resources Board puts out for how California is going to get to its carbon neutrality goal by 2045, includes quite a lot of focus on methane, which is very encouraging. And as you can see, the strategies are for the main sources of emission in livestock, landfills, and energy, and I'll talk about that a little bit more in a second. At the federal level, the recently passed Inflation Reduction Act focuses quite a bit, has a significant focus on oil and gas facilities that emit methane. And in fact, the Inflation Reduction Act at the federal level is the first fee or tax of any kind that the federal government in the US has imposed on a greenhouse gas. As you can see here, the fees are not insignificant. They apply to facilities. They're large-scale facilities, and in the US, there are about 7,200 facilities that this applies to. The cost for emitting tons of methane goes from $900 in 2024 to $1,500 a ton in 2026. That's a significant financial incentive for oil companies and gas companies to stop emitting. And we'll see if it works, but I'm pretty optimistic about this. And again, I'll note that the oil companies, the larger ones, have been saying that they think that they can meet these reduction requirements. So I think this is a very big change, and we'll see if it really promotes technologies as well. All right, I want to spend a little bit of time talking about the primary sectors of emission. Here's the chart, human methane sources. A couple of things to notice. Agriculture is, according to this chart, I never know if these numbers are exact, but these are approximate, I think. Agriculture is the largest sector of emissions for methane. And within that, enteric fermentation, which is primarily burps from livestock out the front end, ruminant animals generate a fair amount of emission. Enteric fermentation is the largest single source of methane, larger than oil and gas. Although if you combine coal mining with oil and gas, the fossil fuel sector is the winner. So let me talk a little bit about each of these. Here we are with agriculture, as I mentioned, enteric. The good news is there's a growing amount of research and effort to identify solutions, and that includes for enteric. You may have noticed that Bill Gates has just invested quite a lot of money in a company that grows red seaweed. Work at UC Davis in particular has discovered that using red seaweed as a feed additive for dairy cows has a significant effect in reducing emissions. Remains to be seen if that will last over time, and there are various different strategies and different feed supplements that different companies are trying and researchers are trying, but there is a fair amount of progress. On the manure side, dairy digesters have been a big approach in California, not without controversy, I might add. So let me see if I want to do this on this slide. And then something, rice in the previous slide, as you may have seen, is about 9% of emissions. Not so much in California, obviously a lot more rice grown in Asia, but California does grow rice and it does contribute. So here's the dairy sector progress gap. You see there's a long way to go to get to the target as compared to the trend right now. Having said that, the dairy industry in California is pretty optimistic that they can get to the reduction requirements that they need, and that's quite encouraging. I mentioned the controversy. The dairy industry's approach is really towards concentration of dairy production because they can reduce the per head emission rate in a concentrated feeding operation more easily, both through manure management and through feed supplements. That's created an environmental justice set of issues. I won't go, I just want to highlight that controversy exists, but we'll see. And I am pretty optimistic about some of the feed supplements. All right, landfills. I've been spending a lot of time looking at waste from landfills. One reason that landfills are particularly interesting is that they often represent large single emitter sites. And so if you can control landfill emissions, you get a pretty good bang for the buck. There are old rules for landfills in terms of caps that capture methane. And we really don't have a strong sense of how landfill emissions work, what the impact of things like rain events, other weather events. And so there's now a growing effort to figure out really emissions profiles for landfills in a much more specific way. And I think you'll see some new solutions coming in the landfill sector. Wastewater is another area. I'm less familiar with that, but we'll start paying more attention to that as we go. All right. Here's the waste sector capacity gap. I put this up because it shows that these are in millions of tons. So we have a gap of about 8 million tons. It's very difficult to close this gap in this sector. For example, compost, it's estimated we need about 100 new composting facilities in California to make up this capacity difference. Whether we're able to do that creates a whole bunch of land use issues, among other things. So there are some challenges in this sector for sure. All right, oil and gas, I'm going to leave to the other panelists who are going to talk more specifically about oil and gas. I want to mention a couple of things on this topic. First, in California, there are about 107,000 oil wells, and many of which, unfortunately, will become orphan wells, meaning that they will be left for the taxpayer to plug and abandon through the government, through CalGEM. And right now it is extremely undercapitalized. So an average well costs about $86,000 to $100,000 to cap and abandon properly so that methane doesn't leak. California has, as of 2018, California had surety bonds in the amount from oil companies in the amount of about $107 million for abandoned wells. And the estimate of the cost to close all the wells once they're done operating is over $9 billion. And so this is a much longer discussion, but it's something that the state really needs to pay attention to. There's now some money in the state budget and the federal budget to start looking at those wells, but not nearly enough. I want to mention one other thing before I hand it over. I mentioned that there is that a 20-year equivalency, the way methane is compared to CO2, the greenhouse gas equivalency between CO2 and methane, over a 20-year equivalency, methane is about 84 times as potent a greenhouse gas. Right now, the regulators, both EPA and CARB, use a 100-year equivalency in which methane comes out at about 20 times as potent a greenhouse gas. So as I understand it, the 20-year equivalency is probably a significantly better estimate of the importance of methane. And from a regulatory point of view, it's important to get that correct so that methane is not undervalued in terms of its importance. And so I'm very hopeful that CARB and EPA are reconsidering that and looking closely at the 20-year equivalency. The other thing is that for the low carbon fuel standard, California, the Air Resources Board uses EPA's preset method leak estimates in the oil and gas sector, which means that they don't get credit, companies do not get credit for reducing their methane. That really needs to change so that as part of reducing the impact of oil and gas operations, methane reduction is part of that overall. All right, that's it for me. So Kevin, I'll send it back to you and leave some time for some questions when we're ready.
Very good. Thank you very much, Ken. Our next panelist is Riley Duran. He's the CEO of Carbon Mapper, an organization that I've come to learn about recently. Riley is the Chief Executive Officer and is a research scientist at the University of Arizona. He also maintains a joint appointment as an engineering fellow at NASA's Jet Propulsion Laboratory, where he supports other Earth science programs. From 2008 to 2019, he served as Chief Systems Engineer for the JPL's Earth Science and Technology Directorate, with a portfolio including spaceborne instruments and missions, airborne studies, research analysis, and applied science. He served as Chief Engineer for the Kepler mission that conducted a major survey of Earth-sized planets around other stars. Riley, maybe we can just have you talk about that, rather than methane. I think that's very interesting stuff. He's currently principal investigator on 2 NASA-funded research projects focused on multi-scale methane and CO2 monitoring, and has led previous projects on the same topic for NASA, CARB, and the National Institute of Standards and Technology. With respect to CARB, I want to note that many of you know Mary Nichols. She's actually on the board of directors for Carbon Mapper. So Riley, take it away. Tell us a little bit about what all the organization does, and then your take on what we can be doing about methane moving forward.
Thank you, Kevin. And can I get a thumbs up? Can you see my slides?
Yes.
Okay, great. Thank you for having me. And yes, I would love to talk about Kepler someday. It's probably more fun to talk about than climate change, but what we're doing today is, in the big scheme, more important and timely. So I want to focus on methane today. And in particular, I'm going to talk about what we're learning about methane emissions in California and globally, and what that improved knowledge might tell us about potential solutions. How do we mitigate methane emissions? So I'll just start with an overview of Carbon Mapper, the program, and the nonprofit. So as Kevin said, we created the nonprofit about 2 years ago. It's based in Pasadena with a public good mission to make actionable methane and CO2 data available to the public and to decision makers to help accelerate climate action. Additionally, it's the name of a satellite program that is a public-private partnership that we helped assemble in California, including the organizations you see represented on the right, including Planet Labs, our commercial partner in San Francisco, the Jet Propulsion Laboratory in Pasadena, the California Air Resources Board, RMI. And so Debbie and Ken and others that are talking today have been with us on this journey for some time now. I'm happy to say that we're on track to launch 2 satellites this fall that will ideally operationalize what I'm going to talk about here in a minute. It started with airborne surveys of methane over the state of California some years ago. Our goal is to ultimately make this an operational system with a constellation of satellites that can provide daily monitoring to provide decision-making, again, at local scale. Again, I want to highlight that all of our methane and CO2 data will be made publicly available to support decision-making around the world. This work builds on over a decade of research and development funded by NASA and other federal agencies on what I refer to as an emerging system of systems of methane monitoring capability around the planet. And what I mean by system of systems is represented in this figure, this artist concept, which shows a collection of satellites, aircraft, near surface and surface-based measurements, things like fence line monitoring, drones, and then on-site surveys by operators. And it's this collection of measurement systems that are necessary to really get our arms around what's happening with methane emissions across the human enterprise, again, globally and here in California. I want to highlight there are 2 primary types of monitoring. Why do we do this, these measurements? One is what I call type 1 monitoring, which is really to get aggregate scale accounting and inventory. So this is what California's Air Resources Board does every year. It's what the EPA does every year, of trying to get an accounting of what the net emissions are from key economic sectors like energy, waste, and agriculture. And it is important because it's to track how things are going, but it's separate from type 2 monitoring, which is direct mitigation guidance. And the way I like to think about it is the type 1 is big scale, what's happening at the scale of a jurisdiction or a government, and type 2 is small scale, what's happening at a piece of equipment or a facility. And these overlap in terms of their requirements on measurements, but these are very distinct use cases and scenarios, and they drive us to focus on different things. I won't belabor the point on the different barriers to operational scale up, but I will say that there has been enormous progress over the last several years, and you can expect this to continue through the middle of a decade as new satellites come online and new voluntary and regulatory programs come online. The takeaway point from this slide I want you to have is there's no single system of measurements. We need a portfolio. And this is an enterprise that spans government, private sector, philanthropy, and academia. To give you a sense of what methane looks like in the atmosphere, I'm going to show you a slide at different scales. And so on the left, this is an example of satellite imagery of methane over Southwest Pennsylvania. So this is oil and gas and coal country. The map's not super interesting. Those colors just indicate relative concentrations of methane. And using satellites that are in space today, we can estimate the total emissions from that region. The region's roughly the size of Southern California. It's about 113,000 plus or minus 32,000 kilograms an hour. Those are the net emissions. But what I want to draw your attention to are these little black circles. Those are individual sources of methane within that area that contribute to that total. And we know that because we use other technology, in this case, NASA designed spectrometers on aircraft flying over the region. So now we're going to zoom into that area. And these false color plumes that you see are individual sources of methane. The larger plumes that you see here are from coal mines. So this is coal mine venting. So those are the larger things. And you'll see little small plumes here and there. And those are emissions from individual oil and gas wells, compressor stations, pipelines in the region. So you're seeing a mix of the combined impact of coal and oil and gas production in Southwest Pennsylvania. this is important because we can put these two pieces of information together to understand both the net or regional emissions as well as these high emission point sources and things that we're not seeing in this scene, which are area sources. So again, this is how we can combine these different measurement systems to get a more holistic understanding of what's happening. The technology that we use to find these individual point sources, and I'm going to focus on this for the rest of the talk primarily, is called imaging spectroscopy. The way I like to explain it to people is think of it as a camera, but instead of having three colors like our human eye sees, red, green, blue, this camera can see almost 500 different channels of information extending into the infrared. And that's important because greenhouse gases like methane and CO2 absorb heat in infrared wavelengths. And it's because of this that we can image invisible plumes of methane and CO2 at the land surface at resolutions of a few meters. And that's fine enough that we can pinpoint exactly where the emissions are coming from and importantly, guide follow-up action on the ground. So as a result of doing airborne surveys like this over the last 6 or 7 years, we've now expanded our coverage beyond California. This work started in California in 2016 and 2017, thanks to support from NASA, CARB, and the Energy Commission. We've expanded it since then to cover over 700,000 square kilometers. 8,000 of these methane plumes have been detected in 21 US states, 5 Canadian provinces and counting. As I speak, one of our aircraft is down in South America, the tip of South America in Chile, mapping emissions. A takeaway from all of these studies is that we see so-called super emitter activity in all methane emitting sectors, energy, waste, agriculture. I'll explain in a minute what I mean by that term. But this is potentially low-hanging fruit for mitigation because if you can identify the relatively small number of facilities that are producing most of the emissions, you can prioritize your efforts to reduce those emissions. So to elaborate on this, if you look at what we've learned over the last several years in doing these studies, we find by comparing these different measurement types, the regional total emissions and what we can measure with individual point sources, that a small number, relatively small fraction of infrastructure out there is responsible for 20 to 60% of the net regional emissions. Now, in some cases, these super emitters are only responsible for 20%, in other cases, upwards of 60%. And the reason that varies is because not all regions are the same. There's different activities. Some regions are dominated by coal production, others by oil and gas, others by agriculture. But the bottom line is this behavior, this small fraction of equipment emitting disproportionately is common to human activity. And, it makes sense if you think about it from this perspective. If you have an irrigation system on your lawn, it's going to leak. It's not a question of if, it's when. And if you can find where it's leaking and fix it, then you can save yourself a ghastly water bill, among other motivations for not wasting water. So that's one thing that we learn is that you can find the high emission sources and prioritize your efforts. The other thing we find is that many of these sources are highly variable and intermittent, and that's what this little movie on the left shows. This is a map of methane emissions in the Permian Basin. This is the biggest oil and gas producing region in the US, in West Texas and eastern New Mexico. And the little dots moving around are just showing you from day to day how the emissions are moving in space and how they're changing in magnitude. Now, if you were to stare at this movie long enough, you would notice that some of these dots don't go away completely. So they're variable, but they're persistent. And some of these sources are very intermittent. And this is important to understand because some of these emissions, rightly or wrongly, are expected. EPA calls them process emissions. That is, they are permitted venting and pressure relief devices. And their emissions are being tracked to some extent. But the rest of the emissions here are malfunctions or leaks. And so it's important to understand and disentangle this information to know where to focus on actual malfunctions and leaks and or where there's permitted venting. And ultimately, if some of that venting could be reduced, particularly if it's unnecessarily wasteful. The last point I want to make on this slide is what I call beware of the looking for your keys under the streetlight problem, is that there's been a lot of focus in studying methane emissions onshore, over land in the US. But it's equally important to pay attention to offshore oil and gas production. Why? Because about 30% of oil and gas production globally comes from offshore platforms, and B, because it's difficult logistically to get out there and measure these things. So we're starting to see, along with remote sensing, we can actually measure methane from offshore platforms. And these are examples that we published in the Gulf of Mexico last year. We can see some very high emissions from some oil and gas platforms, not all. So again, we need to take a global perspective, not just look at the land. We need to look beyond the land if we want to mitigate most of the methane. Now, there have been success stories, and this slide basically summarizes some work that we've done in California with the Air Resources Board and with a number of private sector operators, where we shared the data that I've been showing you with individual operators. And in all the cases where you see green diamonds, the operators took action based on the data to reduce emissions. So here's an example of a leaking oil well up in Kern County. And these are the emissions that we were tracking before it was reported to the operator. Little star shows when the operator was notified, and they very quickly fixed it. And then the little green dots show overflights that happened after that to confirm that the leak stayed fixed. Here's an example of a landfill in Southern California where over a period of several months, we shared data with the operators. They were able to diagnose why the methane was escaping from the landfill, and they were able to take action to reduce it significantly. Here's an example of a pipeline leak in a neighborhood in Southern California that was repaired by SoCal Gas. So this is just an example. I like to think of this as an existence proof that if you make actionable data available, motivated people will take action to fix it. I want to follow on some comments that Ken Alex made about the solid waste sector. One thing in particular that we notice when we do these surveys now over 21 US states is that large active municipal solid waste landfills in some cases are significant sources of methane beyond what is expected. And again, this is what I call outlier activity. And just to give you some numbers, in 2016 and 2017, we did the first full California methane survey with our aircraft. We surveyed over 400 active and inactive landfills and composting facilities, and only 32 of those facilities were emitting above our detection limit. What I mean by this is this particular technology finds these high emission point sources. So we're not finding the low emissions that we expect from most landfills, but what we're finding are outliers. And what's significant about those is these 32 facilities were responsible for 40% of the entire surveyed emissions from that study, including agriculture and oil and gas. In other words, this sector dominated. Those 32 facilities dominated all the emissions we were monitoring from that study. When we extend these surveys to other parts of the US, those other 20 states, and we focus on large active municipal solid waste landfills, we find that this sort of activity occurs at about 50% of them. And it's activity that's not well predicted by landfill gas models. So understanding the causes for this is a big focus for us in some of the collaborations we have with organizations like Ken's and Debbie's, and also with private sector operators and U.S. Environmental Protection Agency. So looking forward, like I said, we're on track to launch 2 satellites this fall. Our plan is to provide global coverage. That's what the little gold map shows once a year, and then sustained monitoring over the purple areas. These are the high priority emitting areas around the world. I show you a little zoom incept of a possible coverage map for California. This will depend on our colleagues at the Air Resources Board who are working with this in this phase 1 demonstration project. But California will be a focus along with some other key regions for sustained monitoring so we can operationalize this. Last point I want to make on measurement is that transparency is really key, and availability. And this is why we've committed to having an open data portal. You can go to our website now. Like I said, there's almost 8,000 plumes that we've detected to date where you can zoom in and look at emissions. And again, we try to balance this data with also publishing all of our information in the peer-reviewed literature and testing it against independent measurement methods so that we have maximum trust and transparency. So I'd like to close now with a few suggested focus areas for California, and I'll just echo a lot of what Ken said, is that there are many areas that require attention. The 3 that I focused on here are based on our experience dealing with high emission sources and initial responses we've seen from various parts of both the technical organizations and civil society. First one's waste sector. Ken talked about organic waste diversion. I will point out that of the 32 high emitting facilities we detected in California, 2 of those were organic waste diversion facilities. They were digestion and composting facilities. So it's important here not just to divert organic waste from landfills, but to track the methane throughout the life cycle, throughout the waste stream. Again, back to my sprinkler analogy, if you manipulate methane like water, it's going to leak. And so you need to stay on top of this regardless of where the organic material goes if you really want to mitigate methane. Second area that requires some focus, I think, is on co-pollutants. We didn't talk about this earlier, but methane often isn't the only thing that comes out of these facilities, and particularly from oil and gas production. I think Debbie will talk more about this, but there are other co-emitted pollutants that can come with these activities that can have localized health and air quality and environmental justice impacts that are separate from the global climate impacts that we're worried about. So these are important co-benefits and also co-incentives to think about. And there are some technical challenges that are preventing us from doing more with co-pollutants. And I think Debbie will talk about that more about knowing your gas, right, composition. And the last point I want to make is methane leakage, is that all of these sectors that we've talked about, energy, waste, agriculture, the methane that's being generated is a function of the activity. In other words, if you put so much trash in a landfill, if you have so many head of cattle, if you produce this much oil and gas, you're going to have some methane leakage. And I think this is an important metric as a society for us to track, is if you can understand the amount of methane lost as a function of activity, and you can trend it and set targets. And there are sectors that are starting to do this. For example, the oil and gas sector is starting to do it, and we should consider doing it for the waste and ag sectors as well, I believe, for biogas. If you can set metrics for leakage and targets for reduction, then it gives you another tool other than just focusing on the absolute emissions. Not saying we shouldn't track absolute emissions and monitoring them, but leakage is one way that I think can help level the playing field, particularly given that a lot of these activities that we're talking about span jurisdictions, right? It's not all under our local control, right? But we can make decisions as consumers about the intensity of products that we bring into a jurisdiction based on these sorts of metrics. So with that, I'll stop and I'll hand it back to Kevin and other speakers. Thank you.
Riley, thank you very much. Our next speaker is Debbie Gordon. She is a senior principal at RMI's Climate Intelligence Program. RMI is the Rocky Mountain Institute, and she co-leads the Oil and Gas Solutions Initiative. She's going to be talking about methane leakage here in a very interesting and exciting way very soon. She serves as a senior fellow at the Watson Institute for International and Public Affairs at Brown University and is an affiliate at the Brown Climate Solutions Lab. Her research spearheaded the development of the Oil Climate Index plus gas, a first of its kind analytic tool that compares the life cycle climate impact of global oil and gas resources. The OCI plus is the topic of Gordon's new book, No Standard Oil. She's trained as a chemical engineer and policy analyst. She's a former director of the Energy and Climate Program at the Carnegie Endowment for International Peace. She began her career with Chevron and directed the energy policy program at the Union of Concerned Scientists. When I found out that she'd worked for Chevron, that cued me to ask a series of questions to confirm that she actually is an environmentalist. And I'm happy to report that she is, and looking forward to her presentation. Debbie, take it away.
Thank you. Thank you so much, Kevin. My comments, as others have said, will really concentrate on the oil and gas sector and California as a policy activator. So first slide, or next slide. Great. You know, I think this is a bit startling, and maybe this is a way to wake us all up now, having listened. Just stepping back, ours is the first generation to really understand climate change. Obviously, this is an issue that's been, you know, discussed really since the late 1800s, but I think we really are able, as Riley was showing, to really measure what's going on and see and witness what's going on. And sadly, I think that we may be the last generation that can do something about it. And that's why I think California, as a policy activator, really a leader of the world on so many environmental policies PCL has worked on, others have worked on, makes this conversation so important. Next slide. So I just want to step back a bit in terms of the work that I do and the theory of change of the climate intelligence program that I'm part of at RMI. We really do focus on these, and it's interesting, you'll see there's almost like a methane molecule on the right, but improving emissions visibility, the transparency, as Riley was underscoring, really is the beginning of the journey. If you can't measure it, you can't manage it. It really, and this has worked against us for the generation where so much focus was on smog. even the work I did early on at Chevron, was all the visible pollution out there, but climate gases are invisible, as Ken said. And so the idea of making emissions visible, everything that Riley is doing, is a critical element of how we actually begin this journey. And then the work I've done beyond is to analyze and attribute those emissions. Carbon Mapper is doing this as well. We're doing this in a lot of different ways to try to understand how what's going on in the ground relates to what's going on in the atmosphere. Ultimately, the market is going to be the single most important part of this, the change that we have to see, but that gets spurred by policy and governments, obviously. And I do think that a lot of these emissions are going to end up being digitized and find their way into trading schemes and economics of global movement of these commodities and activities. And establishing governance and accountability measures for standardizing performance across products and markets are critical. And next slide. So as Ken mentioned, I just wanted to give you a snapshot of no standard oil. There is no standard oil or standard gas. It is the topic of the book that I published with Oxford University Press this past year. I mean, think about it. And this is where this whole Oil Climate Index plus gas project started, to assess the emissions from oil and gas and compare emissions from oil and gas resources. Oil can vary physically and chemically from something like peanut butter to nail polish remover. And gas can vary from like what would be dry wind to bubbly club soda. These are really different things. And because they're so different and their chemical and physical nature is so different, I had asked myself, well, then how do their emissions vary? I mean, if they really are that different, then could their greenhouse gas impacts be the same? And that's what led to the decade-long development that we've worked on when I was at Carnegie, the Carnegie Endowment, now at RMI, with Stanford University and the University of Calgary, to develop what you're seeing here, which is an estimating tool. It's a model, it's an engineering systems tool to estimate the emissions from different resources, depending on how they vary compositionally and how their practices vary in terms of extracting them and shipping them and processing them and refining them, and then actually burning them and using them in different parts of the economy. And so when you look at that whole life cycle, you end up with huge emissions differences, 10x or more, between otherwise equivalent barrels of oil and gas. And those differences are what makes an opportunity. You know, it's like if you go to the store and you only had one choice of cereal, there would be no market. But if you have options to buy different levels of emissions of gas, for example, that really changes the prospects of how a market works, because now there's optionality. Are you going to buy really leaky gas, or are you going to buy gas that really doesn't leak? And that's where some of the work that Kevin and I are doing at PCL to deal with now. And I will just say here before next slide is that we get our data from operational data, from the literature, from company reports, from governments, and we use a lot of satellite data, and increasingly we're using more satellite data to feed these estimation models that that show how different impacts of varying barrels of oil and barrels equivalent of gas, how they compare. And on the next slide, you'll see just an example of, this is modeling 2/3 of the world's oil and gas. And these are the industry emissions. So I excluded the downstream use of oil and gas here. This is the emissions to extract, ship, and process and refine oil and gas. And the dark blue shows, for these 2/3 of the world's oil and gas that we've modeled, it shows how much are driven by methane emissions, how much of that total emissions is because of methane leakage. And about 1/2 of the world's oil and gases we've measured come from methane leakage. So controlling, if you would imagine this whole bar, all of these bars collapsing and all of the dark blue going away, you could see in your mind's eye how much less the emissions from global oil and gas could be very, very quickly by managing the methane. And the next slide. So, I mean, and this is covered already by Alex, but the idea here is that oil and gas industry after agriculture is the #2 source of human-made, man-made methane, but it is the #1 for reduction potential. And the reason for that is really interesting. So gas, or I will say, let me start with the methane side. Methane is a pollutant, and that's what we're talking about today. But methane, because it's 70 to 90% of natural gas, is a commodity. The world, it's the only climate pollutant, when you look at it from the oil and gas sector point of view, that actually has value in the market to be sold as natural gas. And so not leaking your gas means that you'll have more to sell, which means that there's profit in not leaking, or there's payback in not leaking gas. The International Energy Agency, varying on the price of gas at any point in time, has actually said that there is value, like there is payback for not leaking gas. But we're not seeing that change. Despite that, we're not seeing that change happen of its own accord in the global economy. As Riley just showed us, a lot of methane, a lot of gas is leaking. And the next slide. So where do we go from here with, yeah, you could do the next slide, Johnny. Oops, did it freeze? Yeah, so where do we go from here? I've been thinking a lot about California, and oh, no, go back to, it must have been delayed. And back home, oh, well, I don't want you to go back too far, yeah. I've been thinking a lot about California as a policy leader here. And what's really different about what the others were talking about, especially with CAFOs, the cattle feedlots that Alex mentioned, and then also with the waste sector that Riley talked about, those are activities that are happening in the state. And that's something that California legislators are going to have to do, and regulators will have to do about California's methane emissions in the state. What's unique about oil and gas from a California perspective, and I will say relatively unique, because this is something that I think California could lead the world to do, and I'll explain where. California imports 90% of its gas. So California is not responsible for much of the gas that it uses. And this is true, and that gas comes from Colorado, New Mexico, other and Canada and other, other North American producers. That gas, when it leaks over 3.2%, makes it more polluting than coal. And that's something that we don't talk about very much. California does not use coal, but it does import gas that leaks more than 3.2%, making that gas worse than coal in terms of its emissions. And empirical studies are finding, as Riley's studies have shown, that there are leaks in the US gas system and the global gas system beyond that are over this balance point of coal versus gas, making a lot of the world's gas worse than coal in terms of its climate impacts. I will also say that California is a leader in a group of places around the world that share this situation. The European Union imports the majority of its gas. Asia imports the majority of its gas. The reality is, and also the surrounding states in the Pacific Northwest and Arizona import the majority of its gas. That puts California in a really interesting position, because if this gas didn't leak, and if California had policies to actually certify gas not to leak, it could lead the charge for a whole global system of importing gas that doesn't leak. How do you set up standards like that? And I did want to also stress the last point here that, yes, this gas is 70 to 90% methane, depending on the source of it, but the rest of it is toxics and impurities, which we'll talk about next. But you have benzene and toluene and even CO2 in some of this gas. There's just a lot of emissions in this gas that leads to what will be local pollutants and environmental justice issues. And that's true of the 10% of gas that California serves on its own and the 90% of gas that it imports. There are a lot of EJ impacts from this gas, both in North America and worldwide. And next slide. So here's what I've been thinking about, and it's something that Kevin and I have been talking a lot about. Possibly the California legislature will be interested in something like this. If California were to adopt a low methane leakage certification standard for California, for both its domestic gas, that 10%, and the 90% that it imports. That could be reconciled on low intensity, deployment of monitoring technology, using carbon mapper satellite system to confirm that we don't have super emitters, company practices that really do make gas, not leak, stay in the system. Then that could lead to not only California cleaning up the gas of the US, but also sharing this policy as it has with other policies like the low carbon fuel standard over with the European Fuel Quality Directive in Europe, passing this policy guidance on to other jurisdictions in Europe and in Asia. Along with that, by collecting gas compositions from operators to specify the methane and toxic contents of the production and shipping segments of this gas, that could actually really help environmental justice actors where this gas is both coming from and traveling through when it leaks, so that we know how dangerous the gas is when it leaks beyond climate impacts, but in terms of public health. And this could lead to forming a buyer's alliance for low methane leakage gas, because it's one thing to say that these suppliers will clean up and should clean up and will be forced by, say, federal regulation to clean up their gas. It's another thing to say the market works, because there are buyers. There are those that will either pay a premium for or set regulations on buying low methane leakage gas, and having that completed circle between buyers and sellers really activates the market quicker than almost anything else. And this California policy could support the efforts to comply with what Ken was explaining, the global methane pledge that now 150 governments have included and was initiated in the US, have signed up to at the climate conference in Glasgow to reduce methane emissions by at least 30%. It actually could push us to reduce methane even more by activating the oil and gas sector faster than just regulations alone can, because you'd have a buyer's alliance for low methane leakage gas. So next slide. Just in sum, I really believe, and I put California right in the center of this quote, that to achieve great things, two things are needed: a plan and not enough time. And I really think California is realizing that. I mean, California is a leader when it comes to climate policy, and California, and from what Riley was just showing us, we realize there is not quite enough time to solve all these things. We need to press them forward. And on the last slide is just my contact info. Handing it back to you, Kevin.
Debbie, thank you very much. I'm going to break protocol here and ask you a couple of follow-up questions right now. There's roughly 375 million metric tons of methane that are released into the atmosphere every year, courtesy of mankind collectively. And what kind of reduction would you estimate in that number in the event that this proposal that you've just put forward regarding methane leakage and standards on purchasing really takes off, not just with California, but with other states and then internationally?
Yeah, so the International Energy Agency has estimated, and this varies with the price of gas, that without any sort of policy impetus, there could be from 50 to 75% of a reduction of gas leakage throughout the entire global economy. If we take the higher end, because there's a policy like this that has a buyer's alliance for procuring this kind of low leakage gas, that 75% of just the oil and gas contribution of methane could actually get us about 20% of the way to the global methane pledge. 2/3 of the way to that. We want to go beyond that 30%, as Ken said. 30% is not enough. But the reality is, if we could very easily get a 20% reduction, 1 in 5 tons reduced from California leading this charge and it taking off for all the other countries in the world that actually are dependent on buying others' gas, it could really make a huge difference in the marketplace. It would transform it. And I'll also add one more thing. It's a really, not enough time makes me think, we're in a really scary place right now, because up until now, gas has been a domestic fuel. It has traveled in pipelines from one region to another where pipelines connect. That is changing with all of the expansion of liquefied natural gas terminals. California doesn't have them, but almost all other gas importers do. And the natural gas industry is poised to cross over $1 trillion in trade this year as a global commodity. So we're at a moment where gas is going global, and having this type of low methane leakage requirement certification is essential, because if we leak what Riley was showing us, these percentages of gas, especially as super emitters, as gas goes global, we're talking about busting the climate budget. I mean, this pie of 375 million metric tons of methane is going to be much bigger. It's just going to grow because gas is going to come out of the ground faster than ever and move more than it ever has globally.
So 20% of 375 is?
60-ish.
Okay, so 60 million metric tons of methane. Sounds like a good idea to me. So thank you so much, Debbie.
Sure.
I'd like to go to our final panelist, Dr. Scott Kelly. I was introduced to Scott recently in connection with a very impressive slideshow he had put together and was showing around San Diego County regarding methane issues. And he's currently the program director of bioinformatics and medical informatics at San Diego State University. He is a graduate of Cornell University and has his PhD in environmental population and organismal biology from the University of Coronado. And we've asked Scott to zero in on specific biological impacts from methane gas and emitters, or not emitters, but they refer to it as companion toxics that typically come along with the gas when individuals are being exposed to it in their homes or next to oil wells or other sources. So with that, Scott, please take it away.
Great. I am unmuted, I hope.
Yes.
All right. All right, so thank you for inviting me to this talk and to talk about the health consequences. I knew a lot of them, but I learned a whole lot more and a lot of things that I really didn't want to know, but I did. So this is actually a picture of flaring that's going on in the Bakken Shale. And could you imagine living next to this, right? So you're talking about day in, day out, flaring of natural gas that goes on. It's not useful for anybody. I think we just got some great talks about this. No one's getting any use of this. It's going directly in. And the best thing that they're doing is actually lighting it on fire, which of course creates its own raft of pollutants, but it's not useful for anybody except to warm the atmosphere. And the best thing you can do is turn it into CO2 because that's a less of a immediate warming than methane. That's really crazy. All right. So let's talk about the before I do that, I just want to remind people, this is not talked enough about, in my opinion, and when we're talking about climate change, global warming, et cetera, is what it is like to live next to these fossil fuel, what I call hellscapes. And what the fossil fuel industry has done around the world is really amazingly destructive and toxic to the people, plants, and animals that live nearby. So up at the top left, we have the tar sands in Alberta. This is the biggest single scar on the earth of tar sands. And just to give you an idea how toxic and crazy this situation is, they use bulldozers the size of two-story houses to rip up the tar sands and take away the boreal forest, by the way, which, as a biologist, I know is a way to suck down carbon. So they're going to remove our ability as a nature to suck down the carbon and trap it in trees, and they're going to replace it with this toxic zone that is so toxic that you actually have to have robot birds to shoot cannons every 30 minutes to scare away the birds, because if they lie down for even a second on these lakes of toxic waste, they'll die. So we have to, it's so destructive. And one company, one mine in this thing produces 250,000 gallons of toxic waste every single day, Over on the right, we have coal mines. This is a backyard where someone's have a strip mine in coal in West Virginia. On the bottom right, we have the nitric delta. This is a completely polluted zone where the average life expectancy is 40 years of age. So this is just waste oil everywhere, destroying the forest, polluting the waters, the fish and everything. And people live about 40 years. And on the left, we have a fracking. This is, I believe, is this in Wyoming? I can't remember. Oh, no, this is in New Mexico. This is a fracking landscape. And when some people look at this, they're like, wow, look at all these fracking wells. But what I also see is the overall destruction of nature, because they've ripped away all of the plants and animals that live in this entire area to drill down into the earth and release all these gases, right? So and then if you live nearby, what is it like? Okay, so I'm going to talk about what are the threats to public health living near this, and also what are the threats locally in our communities? Because a lot of us don't really think about this very much, because I don't live anywhere near any of these sites, although I use the gas. And I would never live near any of these sites if I could help it. But a lot of people simply can't. So what is it like to live near fracking? I'll talk about air pollution. I'll talk about the frontline communities. I'm going to talk about fracking fluids and wastewater. Talk about a little about use of forever chemicals and what happens with radioactivity. I'll talk about noise pollution. And I'll end up with some of the gas stove debates. So living near fracking, this is a nice thing. If your water lights on fire, you're in big trouble. All right, so what is it like to live near fracking? Well, if you have any kind of lung problems, you're suffering. So if you have any asthma or lung issues, or have you gone through lung cancer, you're breathing in a lot of toxins, and it's really bad for you. So obviously, what things come out of wells? Well, you got methane, which we talked about, but you also got nitrogen oxides like NO and nitrogen oxide and nitrogen dioxide. We have volatile organic compounds that exceed the risk levels set by the government in those areas. Things like hydrogen sulfide, benzene, toluene, mixed xylenes, or formaldehyde. And I don't think I need to tell you people that all of these things, or most of these things, are known cancer-causing things. I would not want to breathe these things. I would not want to breathe them day in and day out for sure. And the situation in 2022 is that there are almost no air pollution monitor stations near the fracking wells themselves. Almost all of them are in urban areas, right? Here's another thing that recently came out, that there's a huge amount of fracking going on in Colorado, in the eastern part of Colorado. And they recently discovered that they did the math wrong, that the nitrogen oxide emissions from hydraulic fracturing were nearly double the state's initial estimates. So if you look over the graph on the right, these are the ozone emissions that are coming from different sectors in Colorado, from the railroad, from lawn equipment, from aviation. There's a lot of emissions. Previously, oil and gas was thought to be double what you have from aviation and half of what's from all the vehicles. But with the new math, and then when they figured out what was actually going on and they did the estimates properly, they found out that the oil and gas sector was producing more emissions than all the vehicles in Colorado. And that is really pretty shocking. 45% of the nitrogen oxide emissions come from oil and gas operations, and 41% of the volatile organic compound emissions. What are the health outcomes of living near fracking operations? So this work comes from studies done by the National Institute of Environmental Health and Safety, and also places like the Harvard T.H. Chan School of Public Health. So what are these risk factors? Well, there's a lot of risk factors. There's an increase in premature births and extreme preterm pregnancies, which is very bad for the development of children. There are low birth weight infants, and pregnancy complications are more common. There's higher infant mortality, as you might expect. There's a greater number of hospitalizations. People have migraines all the time, and you can ask anyone who lived near Aliso Canyon about what it is like to live near a giant leak. Upper respiratory tract infections are more common, and children have there's two times the rate of lymphoblastic leukemia in children. They also did a study that was published in Nature Energy that older people 65 and older that live near wells have a much higher risk of premature mortality of these risks. And when you're talking about living near wells, there was a map they had in this study that showed what it is to live near wells, being close or near, but all of these people in all this area have a higher risk of having health issues because of living near the fracking operations. And this is a really big stretch of land. So what are we talking about? Well, there's nitrogen oxides volatile organic compounds, and ozone that all are either made or created from fracking operations. Nitrogen oxides include nitrogen oxides gas include nitrogen oxide, of course, and nitrogen dioxide. And the VOCs are cancer causing and generate ozone. So outside, you have they are produced by oil and gas operations such as fracking. And then, of course, inside, we have gas stoves. And gas stoves are particularly problematic because you turn them on and you're right next to the source of emission. So they're pretty much equal or greater than a lot of people who live near fracking operations. So the health effects of nitrogen oxide and ozone, according to American Lung Association, are things like airway inflammation, coughing and wheezing, decreased lung function, and the increased likelihood of emergency visits. And I just wanted to point out that when we're talking about emergency visits, we're talking about preterm births, when we're talking about all of these issues like, you know, who goes to the hospital and what they're due and who pays for this? You know, it's not going to be big gas and big oil. They're not going to pay for this. So essentially, our health and the people who live here and their and our health system are essentially subsidizing oil and gas operations because they don't have to pay for any of these hospital visits. Yet their operations are leading to a greater likelihood of these visits. So it's just something to keep in mind when we're talking about overall costs. Who's paying for it? And of course, there's asthma attacks. And a 2016 study that had 350,000 cancer patients showed that if you live near these operations, you were more likely to die early than if you didn't. So this is pretty serious stuff. I wanted to talk about why some of these things are happening, and there's been some really interesting studies about what happens when you have nitrogen dioxide versus combinations of, say, nitrogen dioxide and ozone. So ozone is free radicals, is very destructive, and we know that ozone is very destructive to human tissue. I got to learn this from some of my research because they really used it early days to actually try to treat infections. So before we really had antibiotics and other treatments, they were trying to figure out how in war, like I think it was mostly around World War II, how we could treat wounds. And so one of the things they did was that they squirted, injected ozone, the gas, directly into people's wounds. And they found, great, it does destroy the bacteria and clears up the infection, but it also destroys human tissue as well. So they couldn't use it, and they went to more of liquid-based stuff for sterilization and treatment. So here's what happens when we have nitrogen oxide. I love this study because what they did was they took little peptides, which are part of proteins, and they added nitrogen dioxide by itself, and then they added them in combination. So for instance, when you just had nitrogen oxide, it would cleave the proteins, but when you put them together, it would both cleave the proteins and it would destroy the rest of the aromatic parts of the protein. So it was an extra destructive when you put them in combination to the proteins. And of course, your body is made up of proteins. Your lungs are made of protein. Proteins do the essential work and their essential structure of every tissue in the body. So you can imagine if you're breathing in nitrogen oxide and ozone into your lungs, it's going to gradually damage the alveoli and the airways over time. And if you already have issues with breathing, you're going to have more and more issues as you go along. And I, as someone who suffered from asthma as a kid, if I had been next to these wells, it would have been very difficult for me, for instance, to have participated in sports, and I might have long-term consequences, breathing problems, because some of this stuff just doesn't heal after a while. All right, so some more, if you live really close to these LNGs, and I'm glad this was brought up in the previous talk, so liquefied natural gas terminals have a lot of leaks going on, and they're building them really quickly right now. When you build things really fast with very few, Louisiana, for instance, and Texas, they don't really have any. Every time they exceed their permits for things, the state just simply raises the amount they can pollute. So if you live nearby, you're going to have some serious health consequences. So in Port Arthur, Texas, there's one plant that emits 11,000 tons of sulfur dioxide and particulate matter every year. It has twice the state average of cancer, lung, and kidney disease. Notably, it's 98% Black community, and 2/3 are below the poverty line. So that's, I tell you, they wouldn't be able to put this in other communities because people would just reject it, right? Sempra is also planning a major LNG build out in this area. They're very excited about it, but what is this going to do to the air quality? I certainly wouldn't want to live there. In Portland, Texas, they found that this, I don't know how to say the name of the plant, Chenry, maybe it's a French name, exceeded the permit limits for soot, carbon monoxide, and VOCs hundreds of times since 2018, hundreds of times. So what did Texas do? They just raised the limits. They just said, oh, that's okay. You know, I don't live there. Just raise the limits. The residents talk about flares, burning gas, and air quality has gotten so much worse. There's been an 83% increase in emissions. And of course, this energy company at the bottom line here, down at the bottom here, posted a $648 million profit in 2019, a 38% increase from the previous year. So they don't have to pay for all the damage they do, but they get to take home the profits. That's a lot of fun. And you know who doesn't have any fracking next to their properties? The people who own the oil companies. So you might remember this. This was Rex Tillerson. He has been involved with Exxon's expansion of oil and gas drilling around the world, notably in Russia, by the way. And he refused to have he was like, I'm going to fight this Texas utility to put a water tower that had to do with fracking next to his horse ranch. That is a no-go for Rex Tillerson. Fracking and fluid wastewater, this is something that I came to know pretty recently, is I would not want to drink this water, I'll tell you that. But one of the things that they're doing, and I'm going to talk about water pollution in general. So water pollution, and we are all polluted with these compounds. These are known as forever chemicals. They're per and polyfluoroalkyl substances, PFASs, which you might know, but people just talk about it forever chemicals for a good reason, but you can find them in water resistant things like Teflon or stain resistant, or, you know, Teflon's good, you know, for cooking, and foams. So they resist this thing. And they also act, I believe, as a lubricant for fracking wells. They accumulate in soils, water, and they bioaccumulate in people and animals, which I'll talk about a little later. They have extremely long half-life, hence their name, forever chemicals. And it turns out that almost nothing breaks these things down. I mean, in natural world, they've only found one organism anaerobically in sewage sludge that really break this down, which is a big breakthrough. But remember this, if we're going to have to clean up all the PFOS waste that has been generated by all these companies, we have to pay for all of the cleanup for all of this water pollution that has already occurred and is continuing to occur. And so over on the right here, you can see the reason it's such an interesting compound. These are artificial compounds that are made by carbon-fluorine bonds, which are some of the strongest bonds in organic chemistry. Really difficult bonds to break, and that's why nothing eats them. And more research is coming out about the direct effects of PFAS exposure. This is the National Academies of Science studies that recommended that the CDC and the EPA update their clinical guidance to advise clinicians to offer PFAS testing to patients who have a likely history of elevated exposure. I've gone to the websites and they're pretty weak sauce right now. So the National Academies has come out with guidance that says you really need to tell people how bad these things are. And they have a little list here of all of the different elevated disease and issues that happen to do with having high level of PFAS, delayed development, memory development, reduced response to vaccines. There's lower birth weight infants, thyroid disease, increased cholesterol levels, liver damage, kidney damage, testicular cancer. These are the high certainty that PFASs increase the risk factors for all of these things. Okay, so now what does this have to do with fracking and gas? Well, it turns out that they've been dumping these things into wells probably for 20 or 30 years, right? So I call it salting the earth with forever chemicals because you really can't get rid of these things. Forever chemicals were caught. So the Physicians for Social Responsibility did a study, because I guess the government doesn't do these studies, of how much PFASs are going into these wells. And they found that 1,200 wells in 6 states and over 130 companies have been using and injecting large amounts of PFASs into the groundwater. One fracking site, just to give you an example, one fracking site in Texas put 328 pounds of PFASs into a single well. where it turns out that only one measuring cup of PFOAs could contaminate almost 8 billion gallons of water at a very high level. So these are injected into wells, and they say, well, they're going deep into the groundwater. Well, wells leak. Groundwater, they leak into the groundwater. We know this is happening. Flaring releases these chemicals, and they have ground level pools that are leaking as well. And here's the other thing I want to talk about is bioaccumulation. So bioaccumulation is where it goes up the food chain, basically. It gets into the water and the soil, then it gets into the plankton. The fish eat the plankton, they absorb it in their bodies and they can't get rid of it. The gulls can eat the fish, et cetera, et cetera. So it turns out that eating one freshwater fish could be equal to a month of drinking water contaminated with PFOSs, right? And a new study found that the total PFAS in freshwater fish was 278 times higher than in commercially sold fish. So you're thinking, oh, I'm going out, I'm getting some fish, should be hell safe, it's out in nature, all contaminated PFASs. So now, of course, the fracking industry is not the only one that's dumping these things into the environment, but they're dumping a lot of it, and we really don't know where it's all going. And if we don't stop it, it's just going to contaminate every single water every single water system at a really high level. Okay, so what happens when they're done with their polluted water? So a lot of the things that have been happening is they go into these, they go into these, a lot of these fracking companies, they'll go into a area that has low income, people don't have very much money, and they'll say, hey, we're just going to put a well in here and you get the profits, you don't have to do anything. What they don't tell people is they're going to be drilling for 2 years and they're going to leave behind a huge, big pool of polluted wastewater that they don't, and they're just going to walk away, right? So one example happened in this, in the Navajo Diné Nation land, is that they told these people, hey, you're just going to make money, and then they left behind 59,000 gallons of toxic fracking water, which then leaked, just the dam broke and it leaked out into their ecosystem, and there you go. In 2015, a broken North Carolina Dakota pipeline spilled something like 3 million gallons of contaminated water into nearby creek. So there's all of these fracking wastewater sitting all over the place in these poorly lined, or sometimes, how long are these things going to last? Here's an example on the bottom right of some of these fracking wastewater containment zones. How long are these things going to last? And you sure wouldn't want to drink this stuff. Here's one I looked up recently that was really quite shocking. So one of the things they're doing is they're going to say, okay, well, we'll recycle the water and we'll put it back and reuse it. But the problem is when you recycle it, you've got to get rid of like the radioactivity that comes up with the wells, like radium-226, right? So you can bring it and bring it back, but what they're doing is they're taking out the radioactivity as part of the cleanup process, and then they have to do something with it. So in this Kentucky community found out that they illegally, one of those companies illegally dumped 2,000 tons of dangerous sludge, like highly concentrated radium, I believe it was, in a landfill that was just uphill from their middle school and their high school. I would not want this. So they were really upset to find out. You gotta put it somewhere. You gotta put it somewhere.
So hey,
put it right next to the stove. Yeah, am I going over?
We're running over into our question and answer.
Okay.
So if you could just wrap it up real quickly. This is
okay. Thank you. There's just so much. I didn't know how long it was going to take. I just want to point out that there's a lot of noise pollution if you near there. So I can talk more about that if you like. And then the last thing I want to talk about was gas stoves. So the gas stoves, which is the hot point, is has the same problem. It's sort of like having a little mini fracking thing in your house. So children in households with gas stoves are 42% more likely to have asthma. The annual gas stove emissions are equal to 500,000 cars. There's a linear relationship. The more you burn, the more you have, and they exceed outdoor safety limits within minutes of cooking. You get these high levels of gases. Of course, there's VOCs. And this is what's really interesting and shocked people, but 3/4 of the methane leaked from stoves happened when they were not running. So that's all I have to do. Thank you for your time. Sorry, I went over a little bit. It was a lot. There's a lot that I didn't go over. So I appreciate your time.
all right, Scott, thank you very much. So folks, we're going to extend to 10:35. We'll have a 10-minute break before our 1045 panel. And we have a lot of questions that have come in. I've done my best to kind of cull through them. I have a question from Andy Sawyer, and I'm going to imagine Ken might be the one to answer this. He's talking about the impact of concentrated animal feeding operations. And the question is, are there going to be any incidental effects, good or bad, in connection with water pollution as a result of efforts to deal with the methane problem?
Yeah, so this is the crux of what I was getting at with some of the environmental justice issues. There are lots of pollution associated with confined animal feeding operations. Dairy production in California has moved more towards these confined animal feeding operations, which are quite intensive. And so the dairy industry, at least some of the industry, would like to consolidate further, and that is a way to reduce methane emissions because the manure can be contained and feeding supplements are easier to provide. The side effect is all kinds of other environmental issues that are associated with those CAFOs. And so it's a real discussion that needs to be had. I will say that there are other techniques to reduce emissions from manure that do not require dairy digesters and confined animal feeding operations. So hopefully there's some way to expand those practices as well.
Very good. I have another question here from Jeffrey Gilman. And this I would direct to Debbie. He wants to know whether or not this certification plan regarding methane leakage could contribute to higher gas prices.
Yeah, so first of all, gas prices are out of bounds. I mean, with the war in Ukraine and what's going on with the globalization of gas, everything is, I know where I sit in Providence, our electricity rates that are driven by gas increases just went up 60%. So we're in a little bit of a new normal, I think, for the world. I don't think California is unique, in concerns about inflation, especially in the energy sector. At the same time, there are companies that want to certify and are certifying. I think we have about 20%, the open source certification body that's spun out of RMI called MIQ, they have 20% of US gas currently being certified. Having buyers for that gas will spur that market further. And I think that the jury's out on how that will affect prices, because these are companies that, for reputational, because of ease of operations, because of other considerations, their own climate pledges, they're going this direction anyway. So I don't think it's a one-to-one that this regulation would increase gas prices. At the same time, would anything be blamed on increasing natural gas prices or electricity prices? Absolutely, because they've been going up. It's just a reality that we're all going to have to confront somehow.
All right, thank you very much. At this point, I'm going to turn it back over to Howard for a wrap up. I want to thank everybody for great presentations, and it was just a real pleasure working with you and getting educated on so many things. I will note that I did ask Debbie to draft some legislation on the certification issue, which she kindly did. We roundtabled it with our panel. We finalized it, and we've actually submitted it to some key staff in the Assembly and in the Senate. And we're looking forward to their initial reactions. I personally am quite optimistic that we're going to be able to take this, get it into a bill and moving in the legislature. But then that's just me as an optimist. So Howard, back to you.
I like the optimism, Kevin. It's always good to be optimistic with legislation. So thank you very much. Thank you, Ken, Deborah, Scott, Riley. Wonderful, wonderful presentation and discussion. Learned a lot there on methane. And so we're going to keep, PCL is going to keep moving on this, and we'll keep everyone engaged and trying to figure out how to help solve some of this. And as Kevin was just mentioning, we're we're kind of shopping around an idea right now. So Kevin, thank you very much for moderating and setting this panel up. Thanks everyone for joining us this morning for our first session. We're going to take a short, looks like about 10-minute break or so, and we'll get it on our second session here right at 10:45. Thanks everyone. Hang out if you want. You can log out and log back in if you want. And thank you so much, panelists, for being with us this morning.